Imagine that I have a frame like this, and if I had some amount of water or water bubble or whatever, soap bubble or something, I keep it here, there is no surface, very little surface. And if I now start to pull it, I am actually creating a surface. In fact, I am creating both sides. Now if I have to pull this fellow and lift it up till that place, I have to exert a force F, and I have moved it a distance D. Work done by me is F into D. But you already know that this side is going to pull and that side is going to pull. If this had length L, how much did it pull with? How much? Come on. Sigma into L on this side and sigma into L on that side. So 2 sigma times L. This is water. It's not, I'm not talking about soap film yet. I'm just talking about water. So 2 sigma into L is what I'm creating. Sorry, that is the force I have to exert. So this must be F. F must be 2 sigma into L. So the work done by me is actually 2 sigma LD. But what is LD? Area, but no, it is not the surface area. Because if I pulled it like this, remember there's going to be a surface created on this side of LD and on that side of LD. So 2 times LD together is the area, surface area, total surface area. Because if I have pulled this rod like this, on this side there is a surface and on that side there is a surface. In fact, that is what the surface is, right? That's what I'm creating. So therefore the work done is sigma times 2LD. 2LD is the surface area created. So the work done is sigma times surface area. A is the surface area created. Now what happened to that surface area? If you let it go, it will be pulled back. So it's not completely lost. So it is conserved. So that means it is converted into some form of energy. We call this surface energy. So surface energy is sigma times A. So actually, interestingly, we can define surface tension as the surface energy per unit area. I like to think of it in terms of force because surface tension will directly contribute to force, but you can also think of it in terms of surface energy per unit area. Suppose this was a soap film, then I'm pulling it like that, you will actually have a thin layer, right? Now what will happen is this will become 4 sigma L. So that means the work done will become 4 sigma LD. But the area that you have, surface area is LD, LD, but there is an inner side to this, so LD, LD. So how much is the surface area? 4 LD. So this would have become 4, but the area will also, surface area will also become 4. So the formula still remains sigma into A. So what is the surface energy? Sigma times the area. Area, what area? Surface area. Okay. Now this is a very useful idea because you can use it to solve different types of problems. For example, if I had 1 drop of water, let us say which has radius R, how much is the surface energy? Sigma into 4 pi R square. Suppose I had 9 drops of water and they basically join up together to become a big blob of water. Now, do I have more surface or less surface? Less surface. You can see very clearly that this and that will basically vanish and you will end up with one surface like that. And finally, all that will become this. So, how much do 9 blobs of water have as surface area? Well, each one has R. So, it would have had 9 times 4 pi R square would have been the original surface. This would have been the surface energy initial, not spring energy, surface energy initial. Now when they combine together to form a big blob, generally water volume is conserved because water density does not change. But what was the volume? 4 by 3 pi R cube. Now I have 9 of these guys. 9 is a bad number, I should have taken 27. Okay, let us take 27, but I can't draw 27. Okay, so if I took 27 of these guys, lots of them, then this is into 27. Now that must be equal to the volume of this one fellow. If I call this radius r, this one's volume is 4 by 3 pi capital R cube. And so 4 by 3 pi gets cancelled out. Because the volume goes as R cube, you can see that capital R is 3R. Which means the surface area is 4 pi into 3R square, which is 9R square. Can you see that this is 27R square and this is only 9R square. So this surface energy is lower than that energy total. So this is sigma into 4 pi 9R square. So lot less than that one. From 27 times sigma into 4 pi R square, it has become 9 times sigma into 4 pi R square. So this is of a lower energy than that one. And you know, things move towards lessening their energy. So if you bring 27 drops together, they will join together because their energy reduces. That's what will happen on its own. Okay, so this will join together and this energy will be lower than that energy.